Hi, welcome to our first level 3 simultaneous equations video. In this video we're going to show you how to solve simultaneous equations. Now in level 1 and level 2 you would have come across simultaneous equations that had two equations and two unknowns. These are two-dimensional simultaneous equations and our two unknowns were x and y. Now you may have come across them in this form where both equations were in the form of ax plus by equal to c. You may have come across examples in this form where both equations were in the form of y equal to mx plus c, or you may have come across simultaneous equations where you had one in each form. We're going to focus primarily on the ax plus by equal to c form. Alright, let's get going with example 1. Solve the following simultaneous equations. 2x plus 4y equals 18 is our first equation, and our second equation x plus 3y equal to 10. Now we have two equations and two unknowns. Our two unknowns are x and y. If we only had one equation and two unknowns, we couldn't solve it. So we need to have two equations for two unknowns. Alright, we can solve it in two ways. One is the graphics calculator and one is algebraically. In this video, we're going to focus on the graphics calculator because that's all you need for achieved. If you don't have a graphics calculator, you will have to learn how to solve them algebraically. And if you are keen to go for merit and beyond, you're going to have to learn to solve them algebraically anyway. So we will show you how to solve these things algebraically in later videos, 6 and 7. Alright, so let's grab our calculator and go into the equation menu and push the blue execute inside that menu. Inside that menu, we're going to select the simultaneous equation option, which is F1. Inside that menu, you will find the number of unknowns. Because we have two unknowns, x and y, we're going to select two unknowns, which is our F1 function key again. Inside that menu, you will find where we are going to enter details of our two equations. Now be mindful as we enter in the equations, they're going to be in the form of ax plus by equal to c, so our first equation is already set to go, 2x plus 4y equal to 18. But our second equation, notice there is no number out the front of the x, there's a 1. So when you enter in the details for the second equation, you're going to put the 1 and the 3 and the 10. So we're going to enter them in like this. For the first equation, you just need to enter the 2, enter, 4, enter, and 18, enter. And then for the second equation, go 1, enter, 3, enter, and 10, enter. Now we need to solve these equations, so we're going to push F1 once more to solve these equations, and you're going to get our solution, which is x is 7 and y is 1. So we know that these two equations intersect at the point 7, 1. Right, well now in level 3 we explore simultaneous equations with three equations and three unknowns. This is three-dimensional simultaneous equations. Our three unknowns are x, y, and z. Now we're going to do the same thing, go back into equations, simultaneous, and get to our number of unknowns menu. If you've just been following in the last example with me, there is a trick on your calculator by pushing exit, and that takes you back steps. So if you've already solved the last example, you could push exit a couple of times to get back to this number of unknowns menu. Now this time we have three unknowns, x, y, and z, so let's push F2. And here is where we're going to enter in the three equations. Now be mindful as we enter them in a couple of things. Our first equation, there is a coefficient of 1 by the z, so make sure you enter 2, 4, 1, and 18. The second equation should just be 5, 3, 2, and 10. But our third equation, the coefficient of x is 1, and don't forget there is a negative 2 for z. Well, again, we're going to solve it by pushing F1 and get our solution. Here is our solution. X is negative 2.25, y is 4.75, and z is 3.5. So we know that these equations intersect at the coordinate negative 2.75 for x, 4.75 for y, and 3.5 for z. Right, that's our first video. Thank you so much for tuning in.